Hello, I'm Joseph Kasser, and this presentation is about improving monitoring of project technical performance by using CRIP charts, C-R-I-P. So the objectives of the presentation are shown on the screen. I want to explain so you will understand the need for the CRIP chart or an equivalent. I want you to learn about the CRIP chart and then to understand the associate benefits of the CRIP approach. It allows you to do things that you cannot do in the current paradigm. And I'm going to discuss it in the context of a complex project that takes months or longer to complete, and what we call the system development process. In project management, you probably know about the triple constraints of cost, scope, and schedule. And we measure cost and schedule using EVA, earned value analysis, but currently there isn't anything that's really useful for measuring scope. That's where CRIP comes in, as I will explain in a moment. But first, I just want to summarize earned value analysis. It's based on financial numbers. It tells you the amount of budget you've spent, it tells you the amount of planned work you've done, and it tells you the amount of time that's elapsed. However, it doesn't answer the question of how much of the project has been completed. That's the technical side. And it also doesn't identify potential technical problems in near real time so as to allow you to mitigate them. So we need to measure something that allows you to mitigate, or at least to prevent problems and measure technical process. Now, one of the things we could measure are requirements, because all the work is based on requirements. But they come in various shapes and sizes, and so just because you've completed 50% of the requirements doesn't mean you've completed 50% of the project, and you can end up with a large number of these. Similarly with function points, they apply to software projects or the software sections of a project. They also come in various shapes and sizes. You can have a large number of them, and they can be complex to calculate. In fact, they are complex to calculate. So what we need is something that's usable, something that can roll up the detailed information into a summary that can be displayed on one or two charts, and something that can be readily related to existing cost and schedule information. Now, one of the things I talked about in the system approach to planning video that hopefully you've seen, if not, take a look at it, is a work package in which not only do we identify the work, as in the traditional work breakdown structure, but it has a few other things in it, including traceability to requirements, which is what we need, priority of the work package, which traces back to the priority of the requirements, estimated cost to implement, and the risks. So all these are attributes of a requirement in a sense. So the categorized requirements in process, CRIP approach, is based on all the work done is based on meeting the requirements. And it's 5 steps. Identify the categories for the requirements, quantify each category into ranges, place each requirement into a range, summarize the requirements in the ranges, and then monitor the changes in the state of each of the summaries between reporting milestones over time. And there's a lot more information and detail and examples in chapter 19 of my book, Perceptions of Systems Engineering. So what I'm showing here is just a brief overview. So let's go through each of these in time. So first one is identify categories. Well, these can be things like estimated cost, complexity, priority, risk probability, risk severity, estimated completion time if different requirements are required at different times, technology readiness level, if different technologies at different levels of readiness are used, the function that the requirements does, is it an input function, an output function, a communication function, some kind of processing function, and so on, and other custom categories for the project, and so on. We then quantify each of the requirements, each of the categories into ranges. And these ranges are determined by the buyer and the supplier. So they could be a range 1 to 10 or 1 to 5, commonly associated with risk, A to J, easy, medium, ugly, and hard if they're associated with problems, and so on. The rules for range assignment shall not change over the project lifecycle. So once they're decided, they're fixed. However, the requirements can move between the ranges as the work progresses. So if we find out that the initial estimate and placement of a requirement in the range was wrong, we can move it into a different range. That's fine. And typical examples of ranges, for example, cost. Range 1 would be estimated cost to complete of under $50. Range 2, somewhere between 50 and 100. Range 3, 100 and somewhere else, and so on. Or complexity. Range A, less than 100 function points. Range B, between 100 and 300 function points, and so on. Risk, probability, and severity, 1 to 5, 1 to 10, whatever. We then place each of the requirements into a range, and so we assign or calculate a value for each requirement in each category. So we could assign a priority, and this is the customer's decision. We calculate the risk, the probability and the severity for implementing each requirement. And this could be in terms of what's happening in the process and what's happening in the product. And complexity. We could estimate the complexity of the parts of the system that will perform the function. And we can estimate the cost. And the estimates don't have to be very accurate, which is a nice feature of the CRIP approach. They don't have to be accurate, but they have to be consistent. So it all has to be done the same way. And then we summarize the requirements into a range. So we take a spreadsheet or a tool, if we developed it, and sum the number of the requirements in the range and display them in a histogram like I've shown here. And then, if necessary, balance the numbers by adjusting the range limits. For example, if 90% of the requirements show up in the same range, you may want to spread them out a little to make it a little more usable. And similarly, you take a look here on this chart and you can see that there are very few requirements in range 10. So maybe we want to change the range limits, but for 8, 9, and 10 to spread them out a little bit. Maybe not. Depends on the situation. And then we monitor the change in the state of each of the category summaries of the requirements over time. And these are the system development process states, and you can see here I've summarized them in the Gantt chart, waterfall view, needs, requirements, design, construction, and so on. And then there are milestones that transition between the states of the system development process. And then we have CRIP states and CRIP charts, and what we do is prepare and present CRIP charts as part of a milestone review. And so let me go through each of these things briefly. The system development process has 9 states. It starts with needs identification and so on. And these map into the HKMF that I show here, and the O&M state is shown wider because the system spends a lot more time in it. Each of the states starts and ends at a milestone review. They have different names, and I'm using OCR, SRR, PDR, CDR, TRR, and so on in this particular presentation. And then the start of the project and the end of the project. So each requirement can be in any one of 5 CRIP states at any time. The requirement has been identified, it's in production, that means we're designing it and building it, it's completed, and it's in test, and then it's accepted. And the milestone reviews associated with these states, once the requirement's identified, we will have a system requirements review. The preliminary design review and the critical design review are internal to the internal production states. Once the requirements have been completed, or at least they've been built, then they're ready to go into test. And so we have a test readiness review. After been tested successfully. We have a delivery readiness review, and then the system is accepted by the customer. The CRIP chart will look something like this. Each of the 5 states are shown in major columns. The ranges are the rows, and each state is split into 3 parts: planned, expected, and actual. The P, or planned, links to the work to be scheduled for the next reporting period. E, expected, links to work scheduled at the last milestone for this reporting period. And A links to work performed in this reporting period. So these are how these numbers link to EVA. So let's take a look at the movement in the chart rows. Consider the columns in each CRIP state, and for a particular column, in a column, for example, identified, the planned CRIP chart number from the last milestone becomes the expected number in the CRIP chart at this milestone. So there's no calculations, there's nothing, the number is just copied. It provides a baseline. The expected CRIP chart from the last milestone moves into the actual at this milestone, assuming that the work accomplished equals what we expected. If we achieved more or less, the number will be different. And I'll show some numbers going through the charts in a moment. And then across the columns, the actual in the CRIP chart at this milestone provides an input to what's being planned for the next milestone. So let's take a look and see how this works. Take a look at the partial CRIP chart at CDR for a specific row. So at CDR, if we look at in process, we expected 10. So we expected to put 10 into process, and actual is 10. So we did what we expected. And we also plan to have 10 completed, because there are 10 in process now, and by the time we get to the next milestone, we plan to do 10. And we're also planning to put 20 in process for the next milestone. So now let's take a look at what happens at TRR and how these numbers have moved. Notice that the 20 planned moves directly into the expected in process. We just copy that number. And then you can see that we didn't actually do the 20, we only did 10. And similarly, the planned in the completed column moves at CDR, moves into the expected at TRR. And then if we look at it, we can see that although we actually put 10 requirements into process before TRR, the P number in the completed column is 20. That means we expect to catch up and get all 20 completed by next time. So P moves to E in the same CRIP chart, and depending on the work done, E moves to A in the same CRIP chart, and depending on the work planned, A moves to P in the subsequent CRIP chart. Now, in case you find this difficult, which most people do the first time they see this chart, I'm going to go through some examples of the CRIP chart in use. And of course, that E in process at CDR came from P at SRR. So let's take a look at the CRIP chart at the start of a project for category X, whatever it happens to be. This is we made a bid, our company made a bid based on an RFP, and we went through the RFP and we figured out that there were 279 requirements in the different ranges, and we figured out what it would cost. We made an estimate based on work it all out, and our proposal was accepted. So we then get to discuss that requirement with a customer a little further, and by the time we get to system requirements review, instead of having 279 requirements, we've got 292 requirements, which is fair enough, and I've highlighted the numbers that have changed. So the numbers expected in the identified column are the numbers from the previous milestone, which was the start of the project. But the actual numbers are different because we discussed it with a customer, and a couple of the requirements moved around, there were some new requirements, and so on. So in actual, we had 292, and since this is system requirements review, once all these requirements have been accepted and signed off, we will then start the design work. So the P column in the in process represents that we're going to move all those requirements into the design process. When we get to PDR, what it shows us is everything is going as normal. We expected to put all those requirements into the design process. The design process began, and we're actually doing our design on all those requirements. No new requirements have shown up so in the identified area, so there's no requirements creep going on. This is a good project, and since this is PDR, we're not planning to complete anything by the next milestone, and so the P in the complete column is still 0. When we get to CDR, we can see that we've still got our actual numbers that haven't changed any, but by the time the next milestone comes, our construction phase will be complete, and so we're planning to complete work on all the requirements, so the numbers match 1 to 1. And again, there's been no new requirements, so we're not seeing any requirements creep. This is a nice project. And so we move on through the project, and by the time we get to delivery readiness review, you can see that at the last milestone, which was before testing, the expected and actual numbers match, so work has been proceeding properly, and at DRR, we're planning to have all the requirements accepted by the following milestone review, which is project is over. So this was a good project. A quick look at a project with requirements creep back at PDR. Supposing we'd had some requirements creep at PDR, you might have seen a chart that looked like this. In range 1, 20 requirements showed up. They weren't expected, and you can see that we expected to put 81 in process, but we actually put all 100. We actually added the other 20, and so we have 101 requirements being in process, sort of being designed in range 1. Similarly, in range 2 and range 4, in range 5 and range 7, extra requirements showed up, and we're actually working on the design of the system that will meet those additional requirements as well. And we've got 3 requirements that we're planning to identify after PDR, and that is between PDR and CDR. Now, the chart doesn't tell you where these come from. It could be a rumor we've heard, or could be that we've got an engineering change request with those 3 requirements. But so all it does is it shows us that there is changes going on, there are requirements creep, and we need to ask questions and find out what's going on. Because wait a minute, if we're at PDR already, we should have all the requirements. So what are these changes due to? And similarly, the impact of the additional work on those extra 26 requirements should show up on our EVA cost and schedule charts. If they don't, there's something wrong. There are other examples of using the CRIP charts on both good projects and challenge projects in Chapter 19 of my book, Perceptions of Systems Engineering. Now, some of the associate benefits of the CRIP chart approach is, since we've got requirements tagged by priority and risk and cost, you can ask questions like, are requirements that are low priority and high risk really needed? or low priority and high cost to realize really needed, or requirements that are high risk and high cost to realize really needed. You can ask these questions at SRR, which you can't do at in the current paradigm. And so the customer can say, yes, they are needed, but wait a minute. If they're really needed, why do they have low priority? Maybe the priority needs to change. And similarly, once we have the requirements prioritized, the moment we get a budget cut, we know what functionality is going to be missed. It's the functionality due to the requirements with the lowest priority. And if priority is one of the categories in a CRIP chart, we can actually see if the high priority requirements are being worked on before the lower priority requirements. Because we want the high priority requirements to be completed first. And similarly, if schedule is one of the categories, we can see that the requirements that are needed sooner are being worked on before the requirements that are needed later. And similarly, risk. Risk management plans are mainly printouts from the work package database because we've got all the risk information in there, tagged to the requirements and tagged to the work. And we can produce profiles, risk profiles, priority profiles, and profiles for other categories that you cannot do any of this in the current paradigm. So for example, here's a risk profile at System Requirements Review. You can see that there are a large number of requirements in risk severity 4. Or over here on this one, there's a large number of requirements in risk probability of occurrence 7. Is this a good project to be working on? I don't know. But if we're making a decision between continuing to work on this project and working on another project with a lower risk profile, then maybe we'll go for the lower risk profile. On the other hand, the profit could be higher here. So you have to look at it in context. But you can't do this in the existing paradigm. And similarly, you can come up with a standard risk profile for a type of project, because most projects are repeats of previous projects. Building an airport, building a bridge, developing an oil field, whatever the complex project is, you can develop a risk profile for it. And then you can compare it to risk profiles for other projects, identify the differences and see if they're worth having. These charts are from Tiger Pro. It's an educational holistic requirements management tool that you can find on my website. So are these reasonable? Don't know. Depends on the context. When my students start populating the risk profiles, and I tell them to do it at random, because we come up with a set of requirements for a project, they don't have the domain knowledge or the context, but they can put the numbers in at random, and we can then discuss the risk profiles. And if they end up with projects that have high risk severity and high risk probabilities, which at least 1 or 2 student teams generally do, we can then discuss why they're actually working on that system. It's too risky. So we met the objectives. I explained the need for the CRIP chart or the equivalent. I explained the CRIP chart and the associate benefits of the CRIP approach. And basically it's doing things that cannot be done in the current paradigm. And by the way, if you don't measure requirements, but you measure scenario, if you have a list of scenarios or use cases, or even function points, you can use the CRIP chart for that. Any questions in the usual way? Again, if you want more information, Chapter 19, Perceptions of Systems Engineering, and you can download Tiger Pro from my website and play with it. And thank you very much for taking the time to watch this presentation.